Today we are going to continue converting rates and measurement, but we're going to look at how to convert from one system of measurement to the other. So again, make sure that you have your handy dandy table with you of measurement conversions, because we will talk about how to go from customary units to metric units and vice versa. Do not worry, you will not need to memorize any of these. I will provide you with this chart on any assessment that I give, because you could look these up online anytime using smartphones, things like that. So you do not need to have these memorized. But I'll show you how to use the chart today. So, why might you need to convert from one unit of measure to the other? Well, first, let's just go over some terminology. The customary system of measurement, that's the system that we use in terms of inches, feet, yards, miles, ounces, pints, gallons, pounds, okay? And the metric system of measurement, which most other countries use. So when we're talking the metric system, we're looking at centimeters, meters, kilometers, milliliters, gallons. I'm sorry, not gallons, I meant grams, kilograms. Those types of units are metric. So make sure you know the difference between the two. Let's just start with some basic conversions first. Let's say you have a 2-liter bottle of soda. Okay, because a lot of sodas come in 2 liters, and we want to know about how many gallons is that. So 2 liters equals about how many gallons. So what we can do is we can first recognize what system of measurement we're starting with and what system of measurement we want to go to. In this case, we want to go metric to customary. You can just think about that, but I'm writing it down here. Let's look at our chart, metric to customary. So metric to customary is this side of the chart, metric to customary. And I am going from liters to gallons. So capital L is liters. Aha, look, right here. 1 liter is about equal to, that's what that symbol means, 0.264 gallons. So let's go ahead and write that down. We know that 1 liter is about equal to 0.264 gallons. Now, I will say that all of these are estimated values, all of these conversions. So don't worry if the person sitting next to you uses a different rate and their answer is slightly different than yours. That's okay, because all of these numbers had to be rounded in the first place. So there will be a little difference between solutions. Using this rate right here, let's set this up, 2 liters. I don't have a denominator with a unit, so I'm just putting it over 1, and I'm going to convert liters into gallons. So I want to put liters in the denominator. 1 liter is about equal to 0.264 gallons. And when I go ahead and multiply these values, my liters cancel out so that I'm left with just gallons, I get 0.528 gallons. You will probably need to round your answers. This one you didn't have to round. Okay, so it's about half a gallon. So 2 liters is about half a gallon. So how many liters would make about 1 gallon? About 4 liters would make a gallon. So just an example of, an everyday kind of application here. I do want to show you the same example using the other rate. So what am I talking about? Well, let's say you were looking for liters and gallons back on your chart, and you focused over here. And you went, look, 1 gallon is about equal to 3.785 liters. You could use that one as well. This setup will just look a little bit different, but same idea. So this time I have 1 gallon in the numerator. It's about equal to 3.785 liters. My liters still cancel out. I am still left with gallons. And this time when I divide, I get a long decimal. And this is what I meant, that, someone might get a slightly different answer than you. That's okay. In this case, I might just say round to the nearest 10th, 100th, or 1,000th. And you would get the same thing if you rounded to any of those values, but sometimes you won't. Just know that I'll be looking at your process. As long as your process is correct, you'll gain full credit, because we are working with estimated values. Okay, so both are okay. I'd like you to convert 12 centimeters into inches and 4 quarts into liters. So please do these, use your chart, and then hit play when you are ready to look at the solutions. Okay, so assuming you are ready, here I'm going from the metric system to the customary system of measurement. So when I look at the chart, and again I'll point it out here, going metric to customary, right here centimeters to inches, I will go ahead and use that rate when I set it up. One centimeter is to 0.394 inches. This works because my units cancel out. I'm left with just inches, and I get about 4.728 inches. If you used the other rate, you probably would have gotten 4.724 inches. Again, very, very close. So both would be considered correct. If we take a look at the next example, here I'm going from quarts to liters. Let me set it up for quarts. And if I look back at my table, you can use either one. If I'm going from quarts to liters, I might use this one right here. My quarts cancel out, and when I multiply, I do get 3.784 liters. Okay, those are just single steppers because I wasn't actually working with a rate such as, centimeters per hour or quarts per minute. I was just going from centimeters to inches, quarts to liters. So just one step. Let's take a look at some examples that are a little bit more multi-stepped. So if you grab your handout, let's look at page 18. So this one's a little bit more involved. Number 9. So space station. The Russian space station Mir orbited around Earth at a rate of 463 kilometers per minute. To the nearest whole mile, how many miles per hour was this? So again, we're looking at the space station. Most of the world is using metric, so we're talking kilometers. However, we in America use miles, and let's go ahead and convert this. What are we starting with? Let's look at that first. So we have 463 kilometers per 1 minute, and I want to know how many how many miles per hour this happens to be. So same setup as yesterday. The only difference is that we're converting between units of measure. So we're going from metric to customary. We still want to write down rates that we know. Let's do the time first. We know there are 60 minutes in 1 hour, so we will use that. And now we want to go from kilometers to miles. So kilometers to miles. Let's see. Aha! I happen to have one rate right here that will help. 1 kilometer is about 0.621 miles. Again, if you use this one over here, 1 mile is about 1.609 kilometers. That is fine. There's no problem with that. You'll get a slightly different answer, but either rate will get us there. So let's go ahead and write down what we know. I'm just going to use this rate. You don't have to use the about symbol all of the time, so it is fine if you just want to use the equal sign. I don't mind. Okay, and let's set this up. Again, I'll do my time first. I have my minutes on top so that they cancel out. And now I want my kilometers to cancel out, so I'll put 1 kilometer on bottom with the miles on top. And when I do this, I get this number. It's already a unit rate. Let me go back and read the question though. It says to the nearest whole mile. So I do need to round this to the nearest whole mile. So this would be about 17,251 miles per hour. Now, if you used the other rate, this one right here, you would get a slightly different answer. You would get, I believe, let's see, 17,265 when rounded to the nearest whole number, miles per hour. Both are correct. So even though they're off by more than 10 miles, they're still in the same ballpark and they're both fine. Okay, let's take a look at number 10 because this one's a little bit more intricate. I like this one. What's neat though is that it's the same process. So even though one problem might be a little bit more intricate than the other, dimensional analysis is still working the same way as it did before. And definitely, use the chart to help you. So the world's fastest jet is the Blackbird. It is estimated to reach speeds of over 2,200 miles per hour. Okay, and to the nearest whole meter, so how many meters? We want to know how many meters per minute is this. So let's write down what we know. Let's just do our time first to get that out of the way. 1 hour is equal to 60 minutes. Now, here we have a couple of different options. Okay, we want to get from miles to meters. So how are we going to do that? Well, we might need to make a couple of jumps. So using your table, let's see, we want to go from miles to meters. Well, if I'm looking over here in my customary to metric, miles to kilometers, I see that. Okay, so let me see. I can change my miles into kilometers by using that one. But that doesn't get me all of the way to meters. So what else will I need to use? Well, if I'm going from miles to kilometers, my next step would be to go from kilometers to meters. So what do we know about kilometers and meters? Well, that's all within the metric system, so that's not going to be in that chart. You should know that there are 1,000 meters in 1 kilometer. Now, if you didn't, you can go back to the handout I gave you a few days ago, and I do have that on the back. So 1,000 meters is equal to 1 kilometer. So we definitely have a couple of jumps here that we need to make. But as long as we get from miles to meters, we're good. This is not the only way we could do this. I just wanted to point that out. There are many other options, but that's one way that seemed logical to me. If you found a different path, go ahead and take it and see where it leads you. So 2,200 miles per 1 hour times, let me do my time first, 1 hour 60 minutes. Okay, that's taken care of. And now I want to go ahead and start making my jumps with the distance. So miles, well, let me focus on that first. So I need miles to cancel out. So 1 mile per 1.609 kilometers. Okay, so now I have kilometers per minute. And in order to get from kilometers into meters, I need to use my second rate here. 1 kilometer is 1,000 meters. And now my kilometers will cancel out and I'll be left with meters per minute. So even though we had an extra jump in there, same process, it gets us to where we want to be. When we do all of this math, we will end up getting, whoops, this number. Let me just write it down. Meters over minutes. And let's go back to the directions to the nearest whole meter. It's about 58,997 meters per 1 minute. Okay, I just wanted to point those out. We will work on this a lot in class tomorrow. I will see you then. Thanks.